Okay, so we're going to talk about lesson 10.6, identifying conic sections. In the last 4 lessons, we've talked about the other 4 conic sections, circles, which we have centered at the point HK. Circles, so we have x minus h, that quantity squared, plus y minus k quantity squared equals the radius squared. So always with a circle, it's going to show the radius squared. With ellipse, it looks like a circle because you're adding between the x's and the y's also. But the difference is that we have in the denominator a squared and b squared, which means it's either going to stretch it horizontally or vertically. And the fact that instead of it equaling the radius squared, it equals 1. Hyperbolas, which the equations of them look exactly like the equations for the ellipse, except for the fact that we are subtracting here instead of adding. And with an ellipse, the value of a always has to be larger than b, but that's not necessarily the case with a hyperbola. It can be, but it doesn't have to be. And then we have a parabola, which is going to be either x equals or y equals. And still we're using hk, and h and k represent, instead of the center, they actually represent the vertex of the parabola, and that could open either horizontally or vertically. But the one thing, easiest way to identify that something is a parabola is the fact that there's only one squared term. X is squared if it's vertical, and y is squared if it's horizontal. Okay. So we're going to identify conic sections just from their standard form. So here in example 1, we have a conic section, x plus 4 equals the quantity y minus 2 squared equals 10. And we are going to identify this conic section. And since there is only one squared term here, then this is a parabola. And from what we learned in lesson 5, not only is this a parabola, but it opens to the right. Right? Because it's x equals y squared and a positive y. Okay. So let's look at example 2. Now this one is not in standard form, so we need to get it in standard form. So that means we need to get the x's and the y's on the same side, first of all. And then we're going to divide by, well, we'll look at it a little bit after we get the x's and y's together. And sometimes we're going to divide, sometimes we won't. But so let's take a look at this. First of all, we're going to get the x's on this and y's on the same side. So we're going to subtract 9 times y minus 2, that quantity squared. So we get 16 times x minus 1, that quantity squared, minus 9 times y minus 2, that quantity squared equals 144. And I already know then that this is going to be a hyperbola because it's a hyperbola because we are subtracting x squared and y squared. Okay. So because of that minus sign there, we don't need to do anything else, but it would tell us it's a hyperbola. Now, if we wanted to get the standard form of it, then we would divide both sides by 144 because it's got to be equal to 1. But we don't need the standard form, we just need to get it to where we can identify it. Okay. Letter C. Okay. For letter C, we're going to do the same thing we did with letter B. First of all, we want to get the x's and y's on the same side. So we're going to add 16 times the quantity y minus 2 squared. So we get 16 times x minus 1 plus 16 times y minus 2. That quantity squared equals 81. Now, because of the plus sign here, okay, I know that this could be a circle or an ellipse. And so how I tell the difference then, whether it's a circle or ellipse, is that we are going to look at the coefficients of x squared and y squared. If the coefficients are the same, all right, so let's write this down. Coefficients are the same, that's a circle, all right? And if the coefficients are different, then it's an ellipse. All right, so we're looking for between a circle and ellipse, the plus sign. There's a plus between them, so we know it's either a circle or ellipse because of the plus between them. Two things squared. If the coefficients are the same, it's a circle. If the coefficients are different, it's a ellipse. In this case, they're the same, so this would be a circle. And now it's a circle, but it's a circle that has a center at the point 1, 2, and a radius and has a radius of actually 9/4 because if we divide it by 16, then we would have x minus 1, that quantity squared, plus y minus 2, that quantity squared, equals 81/16, which if I take the square root of that, I would get 9/4. And that leads us to the end of this example. So when we're identifying them, if they're in standard form, if one term is squared, it's a parabola. If they're both squared, separated by a minus sign, like in example B, it's a hyperbola. If they're both squared, separated by a plus sign, like in example C, it's either a circle or an ellipse. And if the coefficients are the same, like they are here with the 16s, then it would be a circle. If they're different, then it would be an ellipse. Okay. So not always are the conic sections in standard form, or can we necessarily get them in standard form. Sometimes they have a general form, and the general form for a conic section is written like this, or you can see it again right here, that ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And a, b, and c do not all equal 0. Some of them could be 0, some might not be. But we have a way of determining whether it is a circle, ellipse, hyperbola, or parabola. So if it's a circle, then if we calculate b squared minus 4ac, and you might remember that from when we were doing the quadratic formula. That's the discriminant in the quadratic formula. We're not using it the same way, but we are using it. And so if it's less than 0, as it says here, and b equals 0, and a equals c. So if b equals 0 and a equals c, it's a circle. If it's less than 0 and either b is not equal to 0 or a is not equal to c, then it would be an ellipse. If it's greater than 0, then it's a hyperbola. If it equals 0, it's a parabola. So the hyperbola and parabola are pretty easy. Greater than 0, equal to 0. But for an ellipse and a circle, then you have to pay attention to the values of a, b, and c. All right, so let's look at our first example here then. So we're going to identify what a, b, and c are to start with so we can do the calculations. So a is always the coefficient of x squared. Coefficient of x squared. B is always a coefficient of xy, and c is a coefficient of y squared. So we've got a is 4, b is negative 10, and c is 5. And we're going to calculate b squared minus 4ac. So in this case, that would be negative 10 squared minus 4 times 4 times 5. So we will get 100 minus, let's see, that's 20 times 4 is 80, which is 20. And since that is greater than 0, then this would be a hyperbola. All right, so because it's greater than 0, we have a hyperbola here. Okay, let's look at another one. All right, so once again, the first thing we're going to do is identify the values of A, B, and C. Now we don't care about the coefficients of x and y, we only care about the coefficients of x squared, xy, and y squared. So in this case, the coefficient of x squared is 9, so that would be A. Coefficient of xy is negative 12, so that's B. And the coefficient of y squared is 4. So we do our b squared minus 4ac again. Okay, one thing you notice the difference would be between this and the discriminant with the quadratic formula is here we're using capital letters and there we use lowercase letters. So we do negative 12 squared minus 9 times minus, there we go, 4 times 9 times 4. Okay, so we get 144 minus, and let's see, that's 4 times 4 is 16, and 16 times 9 is, let's see, let's do a little math here. Let's see, there's 54 and 144, okay. So minus 144, and that equals 0. And since it equals 0, then this is a parabola. And we have one more example here, okay? So this third example then, and once again, we'll start out that same way. So we're going to identify A would be 8, the coefficient of x squared. B equals negative 15, coefficient of xy. And C equals 6, coefficient of y squared. Right? Like I said, we're going to ignore the x term, y term, and the constant. So we get b squared minus 4ac. So negative 15 squared minus 4 times 8 times 6. And we get 225 minus, let's see, that's 32 times 6, which is 192. And that is going to be, what, 33? And that's greater than 0, so this is also a hyperbola. So even though we didn't have an example for a circle or a ellipse, let's see if one of these check it outs is. All right, so let's look at check it out letter A here. And check it out letter A. We've got A is 9, B is 0, there's no xy term, and C is 9. Okay. So if we do b squared minus 4ac here, we get 0 squared minus 4 times 9 times 9. So that's going to be negative, let's see, 81 times 4 is 324. And so that's less than 0. So that means it's either going to be a circle or an ellipse. And so we have to compare the values of A, B, and C. So if we go back up here, if B is 0 and A equals C, which is the case here, then this one would be a circle. Oops. Go back. So there we have when we're identifying the conic sections when they're in general. Okay, last thing we're going to look at is finding the standard form for the conic sections and then determining what kind of a conic section it is. So sometimes we're going to be given them written out in expanded form, and we're actually going to have to use completing the square to be able to get it into standard form. And the one thing we have to do is we're going to have to sometimes factor out the leading coefficient of x squared and y squared. So let's take a look at these. Here's our first example is they want us to find the standard form, then identify and graph each conic section. Okay. So first of all, we need to rewrite it. So we have to put it in, put the x's together, the y's together. And so when we do that, we're also going to leave a space between the x term and the y squared term. And we're going to put the constant on the other side. So now we're going to complete the square. And when we complete the square here then, that means that we're going to do, we're going to write it in binomial form as a binomial squared. So we're talking about a perfect square trinomial. And so the number that goes in this blank space here is always going to be half of the value of b. So in this case, it's going to be half of 8, which is 4. And then we're going to put that number squared here. So 4 squared is 16. And because we add 16 to the left side of the equal sign, we're going to add 16 to the right side. So then we do it for the y term. And half of 10 is 5. So when we square that 5, we're going to get 25. So we're going to add 25 to both sides. And so now we have that 8 plus 16 is 24, plus 25 is 49. So if you look at the standard form here, we have our x squared term plus our y squared term. And because it's a plus between them, we know that it's either a circle or an ellipse. And since the coefficients of them are the same, then it must be a circle. So this is a circle that is centered at the point -4, 5. And it has a radius of 7. And so we're going to, I know you know how to graph them, so we're not going to graph this one at this point in time. All right, so that example was for if the coefficient of x squared and y squared is 1. And so those aren't too bad, but when we have a coefficient of the x squared and y squared terms that are other than 1, then the first thing we have to do is factor them out. So I have it written out here already, what we're going to do. So we have, first thing is, once again, we're going to rearrange. So we put the x's together, left a space, and put the y's together, left a space, and then put the constant 15 on the other side. All right, so we did that first. Then the second step is we're going to then factor out the coefficient of x squared. So in this case then, the coefficient of x squared is 5, so we took 5 out of the x squared and from the 30x, so that left us with x squared plus 6x. And we took the 20 from the y squared and the 40y, which left us with y squared plus 2y. And then the 15 on the other side. So now then, we can complete the square. And so we complete the square the same way we just did. So we only focus on the x squared and the 6x when we complete the square. Now we still have the 5 out front, but it's going to be x plus 3, that quantity squared, because half of 6 is 3, which then when we square 3, we're going to put 9 here. Okay? And we're going to do the y part first before we write it on the other side, because we're going to talk about that together. So then we have 20 times, and half of 2 is 1, so y plus 1, that quantity squared, and when we square 1, we get 1 here. So now when I add to the other side, I'm not adding just 9 to the other side, I'm actually adding the product of 5 times 9, and then here I'm adding the product of 20 times 1. So to the other side, we're actually going to add 45, 5 times 9, and 20 for the 20 times 1. So we have, let's see, that's 15 plus 45 is 60, plus 20 is 80. Okay? So now, here we have the plus sign again between our squared terms, and which means that it's either an ellipse or a circle. And since these coefficients now are different, 5 and a 20, then it's going to be an ellipse. So instead of moving the 5 and 20 to the other side, we're going to, since it's an ellipse, that means we got to make it equal to 1. So we have to divide everything then by 80 because we want to get it equal to 1. So we have then quantity x plus 3 squared over 16, because 80 divided by 5 is 16, plus the quantity y plus 1 squared over 4, because 80 divided by 20 is 4, is equal to 1. So now we have an ellipse that is centered at -3, -1. And so if we graph this one, let's go ahead and make a graph of this. All right, so you know what, let's go ahead and actually make a real graph. Let's find that should be up here. Let's get this out of the way. Come on, come down. There we go. Bring that down a little bit further. Okay, so our ellipse is centered at -3, -1. And let's see, we're going to go 4 left and 4 right, so I need to make it a little bit bigger, or actually just move it over this way. Okay, so we're going to go 4 to the left, because our value of a is going to be 4, so we go to -7 and +1, and go up 2, and down 2, and to the point -3, 1, and -3, -3, and then we'll draw our ellipse there. So, and there we go. And there's our ellipse. So this was ellipse centered at -3, -1. Okay? So you have to make sure in this situation that you are completing the square, so you have to be able to do that. And remember that when I go from my standard form to my factored binomial, that the value of b, it's half the value of b, and I have to put that squared in there also. So remember to do each of those specific things.